Okay, so we're finally to the last part, part 4 of Unit 3C. Here's the homework problems if you did those. Wanted to check them. Inference for experiments. When observed difference in responses between groups are so large that it's unlikely to be explained by chance, the results are called statistically significant. So this is kind of a maybe a newer emphasis in AP Stats, which is on simulations. So we can prove the results are so incredibly large that if we compare it to a simulation, and if we do, and it's pretty large difference, then we say the results are statistically significant. Is talking on a cell phone while driving more distracting than talking to a passenger? It's actually an interesting question. I don't know. So David Strayer and his colleagues at the University of Utah designed an experiment to help answer this question. They used 48 undergraduate students as subjects to drive in a simulator while talking on a cell phone. The other half drove in the simulator while talking to an actual passenger. One response variable, or what they were measuring, was whether or not the driver stopped at a rest area that was specified. So that they kind of had this rest area in the simulation you were supposed to stop at, but I don't know if you've ever done that when you're talking to someone or someone on the phone and you just forget to stop. You just missed the turn. So what happened? So here were the results. We're supposed to calculate the difference between the passenger proportions of passengers who stopped and the proportion of cell phones who stopped. So of the two. So you kind of get out your calculator. Let me get this. It's only handheld. Okay, so if you do, I guess it would be 12 divided by 24 and 21 divided by 24 also, same amount of folks. So I think it was passenger, so it's that second number, so 0.875 minus 0.5 is 0.375. Let's see what they got. Yeah. So you just set up the proportions, subtract them. We're talking about the difference in proportions here of those who stopped at the rest area. So it looks like more of the passengers stopped. So if you had a passenger, you were more likely to stop, right? So 21 out of 24. Wow, about half of the cell phone users did not even stop. They just kept on going. So it was more distracting, I would think. But is that a large enough difference? So what do we have to compare it to? We're going to do a simulation, or maybe they'll do a simulation for us and talk about the results. So 100 trials of a simulation. So they're simulating this by using chance. So 33 stoppers and 15 non-stoppers overall. So they're using the overall rate, not the individual cell phone and the passenger, but they're saying that if there's 33 out of 48 proportion chance of stopping, what would the results look like? So what would a simulation of this? So the simulation is based on this 33 out of 48 number stopped. That's the total number, not the individual cell phone or passenger, but just the total. So they take that and they base a simulation off of it. This is the simulation results. So you can see that 0 is somewhat in the middle, the difference. In other words, we don't expect a big difference between the two because you're basing it on this idea of 33 out of 48, but there's going to be some variation when you simulate, when you flip coins, when you do these kinds of things to get this information. Explain what the blue dot at a difference of 0.125 represents. So they just happen to highlight that dot. There's nothing magical about that dot. They're just saying, what does each one of those 100 dots represent? So that was one of the trials in the simulation where the positive difference, the difference between passenger minus cell phone was 0.125. So one simulated random assignment resulted in a difference in proportions of student who stopped, passenger minus cell phone, of 0.125. use results of simulation. So this is how we can tell. So if you look back, our number was 0.375, right? So looking at 0.375, positive 0.375, do you see that on the chart here, on the graph, the plot of 100 simulations? The largest simulation I see is like 0.29-ish there. So I don't see 0.375. It seems to not be there, right, on the graph. So because a difference of 0.375 or greater never occurred in the simulation, and there was 100 random assignments there, the difference is called statistically significant. Typically, our rule of thumb is it happens in less than 5% of the cases, so 0% of the cases would be a no-brainer. This is statistically significant. That's a significant difference. We don't expect a result that large by chance alone. So this is kind of comparing it. It's extremely unlikely to get a difference this big simply due to chance variation in random assignment. So there's going to be some differences. That's how chance works, but that's a pretty extreme difference. So this is statistically significant. It's a different way of proving causation, of proving that we got a result that was really different because, and that's called statistically significant. Because the difference is statistically significant, there is convincing evidence that talking on a cell phone is more distracting than talking with a passenger, at least for subjects like those in this experiment. So we can't say that's true for everybody, but of the population we're drawing from, the people who were similar to this would be true. So the scope of interest. So random selection of individuals justifies the inference about the population from which the individuals were chosen. So I don't think this was a nationwide, kind of thing here. So it was a smaller group. Random assignment of individuals to groups in an experiment with statistically significant results justifies inference about cause and effect. So if the result is statistically significant, we can say there's cause and effect. So it's a different way of getting to cause and effect. This is just a summary of, table summarizes the possibilities. So there are 4 different options there. You might have inference about the population. You might have inference about cause and effect. So it's how they were selected. So the individuals has to be selected randomly to have the scope of inference, but then they have to be randomly assigned to groups in order to get inference about cause and effect. So researchers at the University of North Carolina at UNC were concerned about the increasing dropout rate at the state's high schools, especially for low-income students. Surveys of recent dropouts revealed that many of these students had started to lose interest in middle school. They said they saw little connection between what they were studying in school and their future plans. When am I ever going to use this, right? To change this perception, researchers developed a program called Career Start. The central idea is that teachers show students how the topics they're learning can be applied to specific careers. To test the effectiveness of Career Start, they recruited 14 middle schools in Forsyth County to participate in the experiment. 7 randomly chosen schools will receive a Career Start curriculum, while the other 7 will use the normal standard curriculum. And it sounds like they were hopefully randomly chosen schools. Good, that's excellent. Students at schools that used Career Start had statistically significantly better attendance and fewer discipline problems, earned higher test scores, reported greater engagement in their classes, and more likely to graduate. This sounds like a great program. So, is it reasonable to make a cause and effect conclusion based on this study? So what are the 2 things we're looking for? So what is the scope of the inference? So I think they surveyed schools in Forsyth County, middle schools. So that's your population, so to speak, that we could talk about. The results were, they were randomly assigned to groups, and the results were statistically significant. So I think we can prove causation. Because treatments were randomly assigned to schools. Okay, wait. That was the next question. Oh, yeah. So is it reasonable cause and effect? Yes, because they were randomly assigned, the results were statistically significant. There is convincing evidence that, I like that wording, convincing evidence, we'll use that in the spring as well, that using Career Start curriculum caused better attendance, fewer discipline problems. So we can actually attribute causation to this one. What is the largest population to which we can generalize? So again, that's because the schools were not randomly selected from any population, only be applied to schools like these 14 middle schools in Forsyth County. This is the last thing is just basic data ethics when you have an experiment. This is just true. There's a review board called the IRB that is charged with protecting safety and well-being of subjects. I think there were some experiments back in the day that maybe they didn't have this board. I think there were some shock experiments that actually may have happened where people were harmed potentially physically in the experiment. I don't think we do stuff like that very often anymore. All individuals who are subjects in a study must give their informed consent before data are collected. So you can't just start collecting data on any folks now. They have to have what's called informed consent. So I did that when I did my eye drop study. I filled out an informed consent about here are the possible side effects, this is what you're signing up for, kind of thing. And all individual data must be kept confidential. In other words, they could talk about me, but not my name. I'm probably only one of many data points that they're going to talk about. They won't talk about me like as really an individual. It's more like here are the results of our studies without names attached. Only statistical summaries for groups of subjects may be made public. So only the group reports actually are made public. So you won't be able to identify, if you look at the results of the study, you won't be able to identify which participant I was there. It's confidential. Okay, so that's the lesson for today. Let's look at a couple of practice problems, make sure we're kind of getting this. You may have heard that Botox is used for cosmetic surgery. It's becoming more and more popular, I feel like. It's kind of surprising, but could it have other beneficial uses? 50 patients with chronic low back pain were randomly assigned to receive Botox or saline injections at 5 different locations in their backs. Okay. The saline injection was not expected to reduce pain, but was given as a placebo treatment. After 8 weeks, the patient's back mobility was compared to baseline measurements taken before any injections were given. The patient was considered to have functional improvement if their mobility increased at least 2 grade levels on the low back pain disability questionnaire. Wow, it's a pretty formal little test there. So calculate the difference of Botox minus saline. We're kind of hoping for a positive difference here because, well, I don't know how the scale works. Okay, so yeah, I think so, yes, if this is the scale. So in the proportion of patients who experience function. So I think you would Botox minus saline solution. So you would get your calculator out, you would do 17 divided by 25, which is that, and 3 out of the 25. Wow, so 3 of the patients actually had improvement. I guess that's placebo effect there. So what is the difference? It looks like a pretty big difference to me, just looking at it. So 0.56, so 56% difference in the 2 groups. Pretty big difference. Okay. So the question here is use the results of the simulation to determine if the difference in proportions from part A is statistically significant. Okay, so we got 0.56. And the question is that statistically significant? Now remember, they're going to do this kind of thing. It's called a simulation. They did 100 trials. It's pretty common to do 100, I guess. Performed to see whether differences in proportions would occur due only to chance variation. So the number they were using there, I don't know if you see it there, but functional improvement, 20 overall improved out of 50. So they're kind of using that as their baseline for both of them when they do this random thing, so 40% chance. But it's a 40% chance for both Botox and saline when they do the calculations. So assuming the type of injection did not affect whether subject experienced functional improvement in their backs, that is 20 improvers out of 50, they were randomly assigned to two groups of 25. The dot plot displays the result of simulation. So you can see you get some pretty extreme there. So user results determine if that difference is statistically significant. So the largest difference I see is 0.4 that happened by chance alone. And that's only 1 out of 100. That's 1%. So even if it was 0.4, I would say it's statistically significant. You want less than 5%. It's not even possible to get 0.56 in chance variation out of these 100 trials. So is it statistically significant? Absolutely, right? Because the difference of 0.56 or greater never occurred in the simulation, the difference is statistically significant. It is extremely unlikely to get a difference this large simply due to chance variation in the random assignment like we had in the simulation. That's all just by chance alone. So we would be very surprised to get a difference that large. So that proves causation. 50 Iranian patients aged 18 to 55 with chronic low back pain were randomly assigned to receive, we just read that. Is it reasonable to make cause and effect conclusions based on this study? So because treatments were randomly assigned to patients and the difference in functional improvement was statistically significant, there is convincing evidence that Botox injections caused an increase in functional improvement. So I have no idea why that would work, but evidently it did. What is the largest population to which we can generalize this study? Well, so they were like 50 Iranian patients who had low back pain. So because the patients were not randomly selected from any population, the results of the study can only be applied to people with chronic low back pain in these 50 Iranian 18 to 55-year-old patients. So it's a pretty small, group you can kind of, generalize to. That's the end of the lesson.